we discussed first Spark application, right? First Spark application. In previous class, we discussed first Spark application, and we developed in IDE, right? We developed in IDE. Spark applications we can implement in Spark applications we can implement in two ways. What are the two ways? One, interactive mode, and second one is batch mode. Right? So interactive mode for development, not for production. So batch mode for production. So once we develop application in batch mode, then we convert into jar file and we run that jar file into cluster. Okay. So in previous class we discussed how to write first Spark application using IDE in batch mode, right? In batch mode, we seen this one. Today what we are going to do, first we'll see interactive mode. Interactive mode. How to write Spark application using interactive mode. Then how to convert interactive mode statements into batch mode, batch application. First we'll see what is interactive mode, how to start interactive mode, then how to write Spark application in interactive mode. Okay. IntelliJ IDE provides both interactive mode and batch mode. So it will provide both interactive mode and batch mode, right? So IntelliJ IDE provides both interactive mode and batch mode. So let's see how to open interactive mode in IntelliJ IDE. Double click on this IntelliJ IDE. Here in this you will see SBT cell. Click on this SBT cell. Type console. It will start interactive mode. Click on SBT cell. Type console. Then it will start interactive mode. Or click on this view. Click on this tools window. Here you will see SBT cell. Click on view, click on tools window, click on SBT cell or Control Shift yes. It will open interactive mode. Okay. So we already started. Then first statement, import the package. Import org.apache.spark._ to import all classes. Next one, create create Spark context val sc equal to new Spark context, and Spark context requires configuration object new Spark conf, and every Spark configuration we set master, set spark dot master, we are setting master is local, okay. Next dot set, I'm setting application name spark dot app dot name, spark.app.name. I'm giving name is interactive interactive application interactive application. That's it. So here we create three statements, right? Configuration object and setting master and setting application name. Finally we pass this object to Spark context. Here also, instead of writing these many four statements, we can write a single statement like this. So we are creating Spark context object. Spark context object requires configuration object. For in configuration object, we are setting master and we are setting application name. What is the advantage of setting application name? By opening Spark Web UI, we can find the Spark application flow, Spark application flow. Okay, so we can find Spark application flow. So inside this Spark application, we can load file and we can perform transformations, right? We can load files, we can perform transformations, we can perform actions, right? Yes or no? We can perform operations, yes or no? We can perform transformations, we can perform actions. So that complete flow we can see in Spark Web UI. Spark Web UI. Let's first create Spark context, press enter. Okay, then Spark context is created. Then display only warning logs. So here if you scroll up, here you will see it is created web UI http colon slash slash, this is the host name colon 4040. This is the web UI. Okay, next set log level sc dot set log level. I'm setting only warnings. Next I am creating one local object. I'm creating local object val list equal to, I'm creating list of 1 2 3 4 5 6. I'm creating some objects. Next I'm creating val r1 equal to sc dot parallelize. I'm passing list object. Okay, next one r1 dot count. So before this, first I want to see web UI. So you can call sc dot UI web URL. Type this one, it will display web URL. Copy this web URL, go to browser, open browser, paste this web URL, press enter. Here you will see complete Spark application flow. So currently we created RDD. What is RDD? We are going to discuss later. We created RDD, means we loaded local object and we created RDD by using parallelize method. Parallelize method. What is parallelize method and what is the purpose of parallelize method? We will see. Simply understand that parallelize method loads local object and creates RDD. Parallelize method loads local object and creates RDD. RDD means it's a Spark data store object. Spark data store object. In languages we have variables, right? Like Spark has RDD. RDD is a Spark data storage object. Okay. What is RDD? We are going to see later in depth. What is a parallelize method? We are going to see in depth. Parallelize method takes input as local object and converts that one into RDD. Okay. So here we created RDD, but here it's not showing anything, right? Whenever we apply any action on RDD, it will load RDD, then it will perform action on RDD. Press enter. So it is showing 6, right? Let's refresh here. Here you will see action. Click on this action. Here it will show one graph. This graph is called lineage graph. This graph is called lineage graph. In this lineage graph, we created RDD by using parallelize method. Parallelize method. So if you perform any sequence of steps, it creates graph here. It creates graph. In this graph, we can see flow of application. So DAG visualizer displays this graph. So DAG scheduler executes this graph. So this graph is called lineage graph. What is lineage graph? Lineage graph contains sequence of flow. Okay. So by opening web UI, we see complete information of our application. Next we executed count, right? Then what I'm doing, r1 dot collect method. Collect method reads all the elements and I want to display each element. For that one, I'm using for each. I'm reading for each element in R1 and I'm passing that element to println. So println prints each element of R1. So these are the elements. Okay, right? We written some statements, right? We executed first, we created RDD. On that RDD, we executed one action called count. Again, we executed collect action. So we executed some steps, right? Then what we can do is, we can save this complete interactive statements into one file. Save interactive. Just I'm giving file name. Click on this save save interactive. Let's go to our Spark application location. So under desktop, under quality thought, under Spark and Scala, under batch 3, under workspace, under first, here we'll see interactive file. Let's right click on this one, open in notepad. See, we written all these statements, right? Yes or no? We written all these statements. Let's copy all these statements and create a new Spark application. Create here new Spark application, Scala application, give second and select object, click on OK, write main method, main function, def main, and inside this one place all the statements. Place this import statement after the class. You can write import statement anywhere in our Spark application. That's it. Let's execute. Run second Spark. Whatever the statements we require, we execute only those statements. So we got output, right? We got count. Count somewhere is displayed. So we got output. We print all the elements in console. So like this, we can write interactive statements in SBT cell. We write interactive statements in SBT cell. Now we created only 5 elements, 6 elements, 1 to 6. We got 1 to 6. So count is 4. Just go to run prompt. Here we see 1 to 6. This is program execution code. Process finished with exit code 0. This is nowhere related to our application, Prasad. This is saying program is completed. So it displayed all the elements, 6 elements from list. Okay. So in this way, we write SBT cell, SBT under interactive cell. We write statements. Then we can convert all these statements into Spark application. Okay. Simple, right? In interactive mode, what we are doing, we are writing step by step statements. Interactive mode. This is interactive mode. We are opening this interactive mode by using SBT cell. SBT cell. This is presented in IntelliJ IDEA. So if you click on SBT cell, it is opening interactive mode. Yeah, Roja. So in SBT cell opens interactive mode, Roja. This one opens, IDE opens what? Batch mode. So our IntelliJ IDE provides both interactive mode and batch mode. We can open interactive mode by using SBT cell option presented in IDE, IntelliJ IDE. Okay. Yesterday I created programs. Assume I close this one. Yesterday I created some application. We saved that application. Next today, I want to execute some continuation part in interactive mode. Yesterday I developed some statements in interactive mode. Then what I did, I saved that statements into one file, right? What is that file? Interactive file, right? Then today I came to office. I want to continue from that. Yesterday, whatever the statements I written interactive mode, I want to continue that one. What I can do is, let's see. So once IDE open, go to interactive cell by clicking on SBT cell. Here type console, type console, type console. Type console. Okay. So here, yep. Now I want to execute yesterday's statements. Then I want to continue my flow. Then use load and file name is interactive. Interactive, right? Press enter. It will execute all the statements presented in that file. It will execute all the statements presented in that file. So Spark context is created, a list is created, RDD is created, count is executed. Next one, it prints all those arguments, all those values. So when I say R1, I'm getting object, right? When I say r1 dot count, I'm getting values, right? Count of that r1. So whatever the statements we saved, right, we can load that statements by using load option. So this feature presented from Scala 10 onwards. Scala 10. So previous, before 10 Scala 10 versions, save and load options are not available. So this is feature of Scala. We are using Scala feature. Okay. So do you have any doubts in interactive mode? Okay. So for Spark we can implement in we can implement in Spark we can implement in Scala, Java, Python, and partially it is supporting R language, partial supporting. Okay. So for this one, we are for this course we are learning Spark with Scala. So we write Scala programs like this. We write Scala programs like this. So first, in before going to implementing Spark applications, let's first learn Scala programming language. Scala programming language. Okay. Scala is a language. First one, Scala is a language. Scala is Scala is both functional, functional and object-oriented language. Object-oriented, object-oriented language. It's pure object-oriented language. It is pure object-oriented language. Object-oriented language. Everything in Scala is object. Everything in Scala is object. Every function returns a value. Every function returns a value. Every value is object. Every value is object in Scala. Every every object is every value is object in Scala. So to store values in Java, we use data types, right? But every data type is a class in Scala. Every data type is a Scala class. So if every function returns value, right? That value is, we are saying, object, because every data type is class in Scala. There is no data types concept. So primitive data types. Everything is a class. So every class is object. So every function is returns value. Every value is objects. That's why we are saying every function is object. Every function is object. So Scala is implemented. Scala is implemented using Java language. Java language. Java language. There are 100 plus languages. 100 plus uh, technologies. Technologies are implemented using Java. Using Java. So for all these technologies, for all these technologies, they require JVM. They require JVM. JVM stands for Java Virtual Machine. Java Virtual Machine. So every Scala program we compile with Scala compiler. Scala compiler. We compile with the Scala compiler. It converts Scala code into Scala class into bytecode. To run this bytecode, to run this bytecode, we require JVM. Scala is a language. First one, Scala is a language. To learn this language, to learn this language, no need to know any language, any other language. No need to know any other language. It's first of all language. To learn any language, it won't require to know any other language. Best example, to learn English, is it required Hindi? No. To learn Hindi, is it required to know Telugu? No. To learn Telugu, is it required to know Tamil? No. Every language has its own fundamentals, right? So Scala has strong fundamentals. Scala has strong fundamentals. Scala has strong fundamentals. Only one thing is, once we compile this Scala code, to run that Scala code, we require JVM. That's it. No need to know Java language. To learn the Scala language, no need to know Java language. If you know Java language, it is add-on advantage to you, because you know already some syntax. It will help you to understand Scala syntax easily. That's it. No need to know any other language to learn Scala language. First point, no need to know any other language to learn Scala language. Scala is a, first of all, it's a language. Okay. So Scala syntaxes are simple. Scala syntaxes are simple. It reduces lot of complexity compared to Java programming. So Scala syntaxes are very simple compared to Java syntaxes. Scala syntaxes are very simple. There are many frameworks are implemented. There are many frameworks are implemented using Scala. They are first we are seeing Spark. Spark is most popular framework, right? This Spark framework is implemented using Scala. And next one, we know what is Kafka. Kafka is most used messaging system. Nowadays, it is mostly used messaging system. Before Kafka, we used JMS, Java Messaging System. If you want to implement a Java messaging system, We need to write a lot of code. We need to write lot of code. So to resolve this JMS programming, there are multiple tools in the market like TIBCO, web methods, message broker. There are multiple tools in the market. The problem with the tools is they are not free. They are licensed version. So initially, Hadoop, Hadoop, what they are doing, Hadoop, if you want to communicate with non-Hadoop systems, they are using JMS. So they want to use Hadoop's technology to connect with other non-Hadoop systems. So they developed Kafka. Kafka. They developed Kafka. Kafka is a Hadoop technology. So any Hadoop can communicate with non-Hadoop systems through the Kafka. The mainly intention of Kafka is that one, but industry using Kafka not like anything. They are replacing all these JMS projects with Kafka. So lot of Java projects are integrating with Kafka, and Spark projects are integrating with Kafka. Hadoop projects are integrating with Kafka. Kafka is mostly used technology. Okay, so in our Spark streaming also, Spark streaming, I will first explain Kafka, then I will explain how to integrate Kafka with Spark streaming. Okay, so I will explain Kafka first, and what is Kafka, how to create Kafka, how to write producer programs, how to write consumer programs using Java technology. Then I will show how to integrate Kafka with Spark streaming. Okay. Next, there are other frameworks like Akka framework, Akka framework, Play framework. So these are web technologies. Web technologies. So these two are using to develop web applications, web apps, web apps. These are most popular frameworks. Akka Play frameworks are most popular framework. There are multiple technologies were implemented. These are some popular Scala frameworks. These are some popular Scala frameworks. These Akka Play frameworks are competitor to Spring framework in Java. There are a lot of projects are implementing by using this Akka and Play framework. If you really search Naukri or somewhere in job portal, you will see a lot of openings on this Akka and Play. You will see Kafka openings. You will see Spark openings. So understand that what is power of Scala. Scala is not a normal language. It's more powerful language. Background we are using JVM, but internal top of it we are writing Scala programs, right? Those Scala programs are most powerful application, most powerful language. So we know that today importance of Spark, right? What is the importance of Spark? Most of the big data processing applications are implemented using Spark. Spark is implemented using Scala. Most of the Java integrations. Yep, nowadays this question, so most of the people thinking that which is the best language to implement Spark. I give clear here. Last 1 year, last 1 year back, how the implementation is. Most of the projects are implemented by using Spark with Java and Spark with Python. 1 year back, how the industry is Spark with Python and Spark with Java is more demanded. more demanded. Nowadays, everyone asking Spark with Scala. Spark with Scala. You will see requirement Spark with Scala more compared to Spark with Java and Spark with Python, because most of the projects are started implementing using Scala. So Scala has lot of features. You can write web services using Scala. Then you can expose Spark application using Scala. Then if it is a web service application, then any application can communicate with this Scala application, right? So lot of features are there in Scala. That's why people are directly using Spark with Scala. And my intention, what I'm saying, first learn Spark with Scala, because first Spark is implemented using Scala. Okay. Then try to write some applications. Try to write some applications Spark with Java to understand syntax of Java, how to implement Spark applications using Java. Next, write some applications using Python. If their requirement is like Spark with Java, then write Spark applications using Java. Only one thing is, here syntax is simple, here syntax is complex. Almost all classes are predefined classes are same. Predefined classes are same. Let's see one simple example. I want to create a list of values, list of values. Okay, for that one, what I'm doing here, I use val list equal to list of 1 comma 2 comma 3 comma 4 comma 5 comma 6. That's it. Then I'm creating RDD. Val RDD1 equal to sc dot parallelize, and I'm passing list. Same thing only in Java. This is Scala. This is Scala. And in Java, how do we do this one is, in Java, we create list equal to new array list, new array list. Then list dot add 1 comma, like this we add elements into this list. So 1 2 3 4 5 6. Then create Java RDD, Java RDD, RDD1 equal to new Java RDD, and pass this list object. Then tell me which is simple syntax. Roja, which is simple syntax compared to about to Java and Scala. Scala is simple, right? So we are writing lengthy code in Java to create one RDD. Here we are using simple this one. Just I am showing how to create Java RDD and how to create RDD. Here also we use Spark context sc dot parallelize method only, and we pass list object. Then we'll get Java RDD. Java RDD. Everything is same. This is complex in syntax. This is simple in syntax. Python also different case. Python is also little compared to, it's look like similar to Scala, but only one thing is, finally, whether you write a Python, whether you write a Python, whether you write Java, finally all these are converted to Scala code, Scala code, Scala code only. And this Scala code again converted to bytecode, bytecode. Finally, all these are converted to bytecode only. So Scala is taken care to convert to this one, Java or Python or Scala or R applications into bytecode. Scala will take care. Once we submit, right, internally these are converted to bytecode. Bytecode is submitted to JVM. JVM executes that bytecode. So that's what I said. So previously people are expecting Spark with Java, Spark with Python. Nowadays everyone expecting Spark with Scala only. Spark with Scala. Still some people are expecting in this way, but only one thing is, if you understand Scala syntax, same thing you can convert in Java, same thing you can convert in Python. Same thing we can convert in Python. Only one thing, syntax and method names are almost same. Whatever the package we are getting, right, you will get, let's open Spark, Spark developer guide. Apache documentation. Click on this Apache documentation. So let's click on any Spark API. Click on this one. Here you will see API documentation. API documentation. Click on Scala. So they will provide complete documentation. Then go programming guides. Click on quick start. Quick start. Here you will see Scala syntax and Python syntax. So this is simple. Scala application, Java application, and Python application. This is Python application. Scala, Scala program, Java program, and Python program. So once you know Scala, right, Scala syntax, almost Java class names are predefined class names are same. Almost program names are same, class names are same. Only one thing is syntax is different. Only one thing, syntax is different. So if you understand Scala syntax, Java syntax, Python syntax, predefined classes are same for all the technologies. So they given separate Scala API, Java API, Python API, R API. All the class names are same. Only one thing, syntax is different. Syntax is different. Okay. So let's first start learning Scala, Scala with Spark. Then we will see how to write Spark applications using Java, Spark applications using Python. I will show some few examples on Java, few examples on Python. Okay. Do you have any queries in today class? So Scala is mostly demanded course. We will see lot of openings on Scala frameworks. Scala frameworks. We'll see Spark jobs. We'll see Kafka jobs. We'll see Akka jobs. We'll see Play jobs. So lot of openings are presented. Openings are these frameworks. So learning Scala, it gives add-on advantage to your career. It gives add-on advantage. In future also we'll see Spark, Kafka frameworks, more demand, more demand. Already these web frameworks also have more demand in the market, more demand for Akka developer, Play framework developer. They are paying more money also. There are no separate training institutes for Akka and Play. Lot of openings are there. So internally they are giving training and they are making Akka and Play developers. Once you know Spark and Spring Hibernate frameworks, understanding Akka Play frameworks are very easy because they are training Java developers and making them as Akka and Play developers. So Spark, if you know Scala language, you can implement Spark. If you know Java, you can implement in Spark. If you know Python, you can implement Spark. Kafka is simple. Kafka administrators creates a setup. Kafka developers writes producer programs and consumer programs. Kafka developers writes producer programs and consumer programs. You can write Kafka producer programs and consumer programs in any language. Apache provided API for multiple languages. You can implement a producer in Java. You can implement a producer in Scala. You can implement a producer in Ruby. You can implement a producer in other language. Kafka provided API for many languages. So Kafka developer means who write application, consumer application and producer application in their languages. It may be Java, it may be .NET, it may be Ruby, it may be Scala. Okay, so that's it for today. Tomorrow class will start Scala practical part. So tomorrow we'll discuss some more important points about Scala. Then we will start a practical part of Scala.